Section 3.1, number 28. We're given that f of x is equal to minus x squared minus 4x plus 1. We're asked to describe the graph of the function and identify the vertex and use a graphing utility to verify your result. I will leave you to graph this yourself. It's very easy to plug into graph or y equals this. Okay. Now, if I'm asked to describe a graph, something like this with a polynomial, the important things that I want to know is what happens way at the tails, right? Does it blow up to infinity, to negative infinity? I want to know if it crosses the x-axis anywhere. And since this is a quadratic, I know that it's going to have either a maximum or a minimum. And I want to know which it is, and I want to know where that occurs. All right. So, looking at this thing, f of x equal to minus x squared. This minus already gives me a lot of information about what's happening here. It's a negative x squared. That means it is a quadratic that opens downwards. Okay? If it's a quadratic opening downwards, that means that this thing has a maximum somewhere. Okay? It goes off to negative infinity on both the positive and the negative side. Okay? It's going off to infinity in both directions, okay? But it has a maximum somewhere. Okay? So that's our vertex. We need to figure out what that is. If I want to look and see where this thing crosses the x-axis, I want to find the zeros of this function. The zeros of this function can be found by using the quadratic equation tools that we had last time. We can either use the quadratic equation, or we can factor it if we can figure out a way to factor it, or we can complete the square. Since we're going to do parts of the completing the square inside of parentheses to figure out where the vertex is, let's just use the quadratic equation to figure out where the zeros are for this thing. All right. So the quadratic equation says x is equal to negative of our negative 4, so it's a positive 4, plus or minus the square root of quantity negative 4 squared. And yes, I do want parentheses around this because that's going to indicate that that negative is going to go away. Minus 4 times a, which is a negative 1, times c, which is a 1, all over 2 times my a, which is again a negative 1. So this is going to give me x is equal to 4 plus or minus the square root of 4 squared is 16, negative times a negative is a positive, minus 4 times a negative 1 times 1, 4 times 1 times 1 is 4, negative times a negative is a positive, and that's going to give us a plus 4. And this is over a negative 2. 16 plus 4 is 24, so we can write it that way. 4 plus or minus the square root of 24 over a negative 2. 24 is 4 times 6. So I can write this as 4 plus or minus the square root of 4 times the square root of 6 over a minus 2. And the square root of 4 is equal to 2. So we're going to get, this is 4 plus or minus 2 times the square root of 6 all over a negative 2. Now I could break this fraction up. X is equal to minus 4 halves plus or minus plus, right? If I incorporate this minus sign into there, it won't change which ones they are, right? But 2 divided by 2 is 1, and I get the square root of 6 left over. This is going to be minus 2 minus or plus the square root of 6. So our two zeros, minus 2 minus the square root of 6, numerically this is about negative 4.45-ish. Okay, and the positive one, negative 2 plus the square root of 6, is about 0.45-ish. Okay, so one of our zeros is on the negative side of x, one of our zeros is on the positive side of x, So it has to look something like this. Okay? Our negative one is much farther away from the x-axis than our positive one. So this is about 0.45. This is about negative 4.45. Okay? So that gives me my zeros. It gives me my general shape. Now what I need to do is figure out where this maximum occurs. To figure out where the maximum occurs, we exploit the tools that we developed for finding our completing the square. Right? So in this case, I have a negative in front of my x squared. I need a positive 1 in front of the x squared. So if I pull a negative out of the pieces with the x in them, I'm going to get an x squared plus 4x. The plus 1, well, that extra constant doesn't really give us anything, doesn't really gain us anything when we do completing the square. So I'm going to leave that outside of parentheses. So I haven't pulled the negative out of it, so it maintains the same sign. Okay? If I redistribute this negative, I get exactly what I did before. So I haven't changed the function at all, I've just changed the way it looked. So now what we want to do is we want to find the number in front of our x. Let's call that b. We calculate from that b over 2. Well, half of 4 is 2. And then we square that. 2 squared is 4. Okay? Now we add that and subtract that inside of our parentheses. So it's going to look like this. The plus 4, the plus I always want to associate with the rest of my quadratic. The minus is going to be just carried along for the ride, and this plus 1, that's still outside. I haven't done anything with that. All right. So now I need to group this thing in such a way that my next step makes sense. This x squared plus 4x plus 4 I have constructed to be my square. So I want to treat that as a chunk. Okay? So I have minus this chunk and that chunk. So when I distribute my minus, I need to distribute it to both of my pieces. So I'm getting a minus x squared plus 4x plus 4 minus a negative 4 is going to be plus 4, and this plus 1, well, that's still hanging around outside. I haven't done anything with that. Okay, now can this be simplified? I have constructed this part to be my perfect square. This has to be, if I've done it right, x plus my b over 2. My b over 2 was, of course, 2. Okay? This negative, well, that was outside of the original thing, therefore it has to be outside of this thing. 4 plus 2, well, hey, I can do that. I can even do it right, this time anyway. So this is going to give us negative x plus 2 squared plus 5. If you graph this in our original function, what you're going to see is we're going to see that they are the exact same graph. Right? They are the same function. They just don't look the same. Welcome to math. Things can be the same and look completely different. But our center for our vertex is going to be the negative of this thing. Right? Remember when we were shifting these graphs, adding something made stuff move in the negative direction. The same thing is happening here. I'm adding a 2, that means my center is shifting to the negative side by 2, right? So their center is at x equals negative 2. And when x is negative 2, well, negative 2 plus 2 is 0, 0 squared is 0, negative of 0 is 0. We are up at 5. So this maximum occurs when x is negative 2 and y is 5. So the maximum point here is at negative 2, comma 5. Okay? Or write it down here, negative 2, comma 5 is my vertex. And it is a maximum. It's a maximum because that is a negative 1. All right. Thank you.